Alright, hello everyone. Today we're going to be talking about electrochemistry. Specifically, we're going to be talking about a non-spontaneous cell, a non-spontaneous electrochemical cell. Sometimes this is called electrolysis, or in the industrial world, electroplating. But this is essentially an electrochemical cell that requires an input of electricity to work. So you're not going to set this together and you're not going to get a voltage potential that is positive. It's not going to produce electricity. It's going to require electricity to work. So, as I said, grab my notes. As I said, this is a non-spontaneous cell. What that means is this cell is essentially going to have to be plugged in. It's going to require an input of energy. Now, there's a couple of important things to note. There's a couple of important facts, and they're not going to seem really relevant at this time. But in about a minute or two, they are going to be pretty important. So one of the important facts is that about 96,500 coulombs equals 1 mole of electrons. Okay, so about 96,500 coulombs equals 1 mole of electrons. And then an amp is the same thing as a coulomb per second. Okay, so an amp is the same thing as a coulomb per second, and about 96,500 coulombs is 1 mole of electrons. So I know that if I plug this cell in, and if 96,500 coulombs goes through that cell, essentially I've put 1 mole of electrons into that cell. And since electricity is just electrons moving through a wire, this is electricity. So let's say we have an example. Let's do an example. Grab my notes here. So let's say we know how much electricity there is. Let's say we have, I don't know, a 10.4 amps of electricity. Alright. Let's say pass through. And we're going to call it a, just for fun, we'll do a Cu2 plus to copper cell. Okay, so it's copper 2 plus ions going to the metallic copper state. Right? This would be true for any equation on your reduction potential sheet. So you could do this for any equation on your reduction potential sheet. Most of them are very similar. The only thing that matters is how many electrons are in the balanced equation. Say after 20 minutes, how much Cu forms? So I have electricity, I have an electrical current, 10.4 amps is passing through this cell for 20 minutes. And I want to know how much copper forms. Well, if we think about it, all this is essentially stoichiometry. All this is essentially stoichiometry. Let me erase this top part. I'll keep the example for now, but I'll have to erase it in a second. My balanced equation is Cu2 plus 2 electrons yields solid copper. This is from my reduction potential sheet. And this, it takes 2 electrons to turn one copper ion into a solid copper piece, right, or a solid copper atom. Well, I can just use stoich, like I said. Let me erase my example here, so I have a little bit more room. Well, I know that I start with 20 minutes. Well, I know that that equals 1,200 seconds. 20 minutes is 1,200 seconds. 20 times 60. I also know that since an amp equals a coulomb per second, 10.4 amps equals 10.4 coulombs per second. From here, I can calculate how many total coulombs pass through. And since I know the ratio of coulombs to moles of electrons, 96,500, I can calculate exactly how many coppers formed. So let's try that out. So I start with 1200 seconds. I know that I have, in every 1 second, I have 10.4 coulombs. I also know that 96,500 coulombs equals 1 mole of electrons. From my balanced equation, I know that for every it takes 2 electrons to convert 1 copper. So 2 moles of electrons converts 1 mole of copper. And then last but not least, from my periodic table, I know that 1 mole of copper weighs 63.55 grams. So here's my equation. I start with time, and I know the current, so I'm able to take my time and the current and convert it into moles of electrons. I'm able to take my moles of electrons and convert it into moles of copper. I'm able to take my moles of copper and convert it into grams of copper. Let's just double check. Let's make sure that everything crosses out. I have seconds here on the top, and I have seconds here on the bottom, so those would cancel out. My coulombs would cancel out, because I have 1 on the top and 1 on the bottom. My moles of electrons would cancel out. My moles of copper would cancel out. And the unit I'm left with is grams, or grams of copper, to be a little bit more specific. Okay, so all we do is we plug this into our trusty calculator. I forgot to do this ahead of time, so I will take a second now to plug this in. So 1200 times 10.4 times 63.55. So this is going to equal 793,104 divided by 2 times 96,500. I don't want to make a mistake with my mental math, so I will do it on a calculator just in case. Okay, divide those two. And I get 4.1. Let me do my sig figs very quickly. Of course I only did 1 sig fig. So I have at the end 4 grams of copper metal. So if I have 10.4 amps travel through this cell for 20 minutes, I will get 4 grams of copper at the end. Okay. So hopefully you understand a little bit more about how we convert between an electrical current or electrical charge and eventually our grams of our metallic substance. All right, I hope this cleared it up. Thank you very much.